All right, good afternoon and evening, everyone. I just want to caveat this video. If you're looking for like the impacts and a forecast of snowfall totals and stuff like that, this is more intended to be kind of an in-depth meteorological discussion of kind of what we're expecting with this system. So it's not going to be for everyone. It's going to definitely steer towards people who have more of an interest in meteorology, looking at some of what the models are showing in terms of the actual dynamics and things like that. I will say right off the bat, if you need those forecast parameters and things like that, snowfall totals and timing, you can go to the National Weather Service website, click on our area, then you can go down to the weather briefing that's on here, and you can go through this briefing that covers watches and warnings and things like that are out right now. Again, those totals and things like that are also found if you go back to just our webpage, the winter weather. You can find discussions and probabilities for our snowfall totals. The rest of this video is going to definitely be more diving into the weeds and more the meteorology as to what's going on with the system and why it has so many people, meteorologists alike, excited and interested. So now let's transition over to a bit more of that discussion. So just looking at water vapor right now, all the pieces are in play for what will be the system tomorrow. Have our southern stream moisture, strong jet across the southern U.S., and then our diving shortwave that is going to be the really remarkable piece of this whole system when it's all said and done as we move through tomorrow. So currently, if we look at the water vapor, we can use that as a proxy for potential vorticity, which is a thing that's always output on a lot of model websites. So just look at what the GFS currently has for its 2 PVU surface, and it lines up pretty well with what's showing up in the water vapor. So that's a good sign in terms of the forecast being on track for what we're expecting, where models are handling the current observations pretty well. So let's get into what exactly is going to happen over the next 24 to 36 hours. We have that diving shortwave that we just looked at in the water vapor. It's going to interact with that southern stream jet and bomb out basically across the southeastern United States. And it will develop into what is one of the more anomalous 500 millibar troughs that we have seen in quite some time. And based on the timing and where it's going to occur, we'll be able to get strong dynamics from both the kinematics of the system, from divergence to the mid-levels, and then strong warm advection below that level in the 850 to 700 millibar levels. So in terms of how anomalous this is, it's kind of stretching into the realm of believable whether it's actually going to happen or not, because it is remarkable how potentially anomalous this is. So right here we have the Jacksonville sounding climatology, and we're looking at the 700 millibar temperatures in Celsius. And the all-time coldest temperature that's been measured from the Jacksonville soundings is up here at minus 15.9 degrees C, and that happened right here on this data point. You can see all the other, most of the other mins for daily mins are in that 15 to 12, minus 15 to 12 range. Now, keep that number in mind, 15.9 C. If we take a look at what the ECMWF is outputting for Jacksonville's minimum temperatures at 700 millibars tomorrow, it is like minus 20 to minus 21 C. So you're talking like multiple standard deviations below the current min, which is a remarkably anomalous air mass that is a big reason why we're expecting to see this pretty significant and historic snowfall event across our area. So that's the primary ingredient, just kind of an outrageously deepening and cold low, and that's going to be important for a lot of parameters when it comes to the snow growth, where we're expecting to see dry air, where dry air matters and where it doesn't, things like that. So looking more at the anomalous nature of this event, this is the ECMWF's Extreme Forecast Index, which looks at the European ensemble and effectively looks at the tails of the distributions and shows how anomalous those tails of the distribution are. So it looks at kind of the more extreme scenarios already and then shows how extreme those extreme scenarios are. And in this case, we have a EFI of 0.99 to 0.1, so basically a maxed out EFI across the Western Midlands, and then a very high EFI all the way in the Central Midlands and into the CSRA. These little hatches here are something called shift of tails, which again is just another measurement of how anomalously those high-end members of the ECMWF are. And you're seeing shift of tails here of between 5 and 8, and then potentially as high as 10. So the reason these values are so high is because we usually don't see a lot of snow. compared to what the ECMWF has in its reanalysis. But the fact that we're seeing both a very, very high EFI signal plus a high shift of tails shows that this is expected to be a historically anomalous event for our area. If you then look at the NAFIS, which is the Canadian and the GFS model ensemble, and look at the anomalies there, you can see basically the blues and the purples are anomalous. In this case, the 500 millibar trough in the NAFIS for the plus or minus window around our current date is a minimum of all time for that window. So this is the strongest trough that the GFS and the Euro have in their reanalysis data set that goes back a certain amount of time, 30 years, I believe. So a historically anomalous 500 millibar trough is the driving feature of this system. We still see those very, very low 500 millibar or 700 millibar temps here, and that continues all the way down to the surface. So now if we kind of look at how we expect tomorrow to play out, we know it's going to be highly anomalous from a synoptic standpoint. If we look more at what the href here has, this is just the LPPM, so the local probability matched mean. So it takes all those href models and kind of lines them up spatially and then gives what should be a reasonable depiction in terms of what the reflectivity will look like. And I will note on here, there's no precipitation depiction in this. It's just going to be the reflectivity. So as we move through overnight, we're probably going to see some increasing shower activity, especially down across the south, but temperatures will still be above freezing and not expecting much in the terms of impact. Could have some refreeze tomorrow from this precip that falls, but no major impacts. Bit of a lull as we get into the overnight hours, and then things start to ramp up early tomorrow morning. That 500 millibar trough in this case is now starting to dig. We start to see kind of overspreading of precip, especially across the upstate, where we're having that strengthening warm air advection from basically below 500 millibars, and a little bit of upslope flow that's also helping with that in the upstate. And then as we move through the morning, precip becomes more widespread, moving along the I-20 corridor, and then overspreading the area with much more intense precip in the afternoon and especially into the evening. And then eventually this moves out by early Sunday morning. So overall, kind of the timing of this, and based on what the href has been showing the last couple of cycles, expect some light precip tonight, maybe some snow, sleet overnight tonight. Not really any major impacts. And then things will kind of steadily deteriorate throughout the day tomorrow, with the most impacts and the highest accumulation occurring generally in the afternoon and evening. So why is the href showing this, and what are some notable features in the soundings? So this is taking a mean of the sounding from the href, plotting it on here. I'll try to talk about what's going on a little bit more, but I'll walk through a timeline of this. So let's start here at 8 p.m. tonight. You can see we have a lot of dry air still in the low levels. So anything that does fall, we could have some wet bulbing as things evaporate and cool. So we move overnight, that layer slowly saturates at low levels. And then now this is at midnight. And this is where we could see some of that brief period of sleet or snow, where we have this warm nose that's pretty close to freezing. And then overnight, that warm nose kind of just sticks around freezing for a few hours. And then steadily, as that trough approaches, that warm nose gets eroded and the whole column cools dramatically throughout the day, and especially into the evening. So a couple things to note here, say let's look at 4 p.m. Saturday. So in this case, we're looking at the column temperatures here from -20 to -10, which is our dendritic growth zone. So this is the most efficient area for snowfall growth. And in this case, it's fully saturated based on what the href is showing. And basically that entire layer is going to be where our snowfall is going to occur from. And if you look higher up at 500 millibars, it's very dry air aloft. So this entire system is going to be fairly self-contained to the lowest few levels of the atmosphere. And it's more like forecasting something like a snow squall with extremely, extremely cold column temperatures versus a typical winter storm where we would see those cloud depths a lot deeper. So this storm is going to be fairly shallow, but very robust and cold. And that's how we're expecting those temperatures, that snowfall to occur. Look a little bit more at this. I showed this yesterday in a quick video. This is the Theta-E fields at 850 millibars, and we see, again, really there's not much change here from what we've seen as that low steadily moves further to the southeast and intensifies. We see increasing Theta-E advection all across the Midlands and down into the CSRA, and this is the area where we're expecting the heaviest snowfall to occur as Theta-Evection is a great proxy for both lift and moisture advection, which is a great way to get snowfall, especially when your column is very shallow but very cold. So 850 lift is going to be the big driver for the snowfall in this event. And then again, here is basically looking at kind of the same idea. This is a 850 millibar temp advection. So as we move into Saturday afternoon, see that strong area of temp advection developing kind of from Columbia north towards Charlotte. This is going to be the enhanced lift, the really, really good snow growth zone. And this is where we're expecting that heaviest precip to really start developing as early afternoon and then move into the evening with that strong area of warm advection, generally along I-20 and north. So there's been a lot of talk about a potential dry slot developing. This system is very different than what we normally would see from a winter storm. And again, I talked about how shallow the air mass is. So if you're looking at dry slots with 500 millibar relative humidity, it may not be depictive of what the system's actually going to experience. We're expecting that dry air aloft because of how intense this 500 millibar low is. But here I'm looking at the 700 millibar relative humidity, and I'm looking at the 0th percentile in all of the LREF. So this is the Canadian, GFS, and Euro ensembles together. This is basically the min in the entire ensemble from the 12Z run. And the reds here are those really, really low relative humidities that are wrapping around that low as it strengthens, and the blue is generally basically clouds in this case. So as we move Saturday morning, that dry air is generally still west of Atlanta. As we move into 1 p.m., that kind of generally dry air stays south of Augusta. And by 7 p.m., it's still south and moving off the coast. So there's not a big signal in the guidance for a notable dry slot in this event. It's definitely a different setup, and yeah, there'll be a lot of dry air aloft, but that's to be expected with this shallow and very cold air mass. Again, here, this is a wrap sounding during the height of the event. Just wanted to show this again. This is showing surface temperatures down around 18 with basically all that lift occurring from just above the surface because the dendritic growth zone is not going to be far off the surface during the height of this event. And then that lift is all really lined up directly through that -10 to -20 range, which is going to yield those really impressive rates. And then again, just a quick mention on the ratios with this event. Again, if you're looking at stuff online, it can be tricky. Some stuff is 10 to 1, some stuff is Kuchera. Some stuff is going to be the MBMs or the National Blended Models, SLR. And generally, 10 to 1 is going to be too low for this event. It's just way too cold when the entire column is basically -10 or lower. Kuchera is a little bit more of a reasonable ratio for this. It's generally in that 15 to maybe as low as 18 to 1 ratio during the event. The MBMs, SLRs were closer to 20 to 1. So just keep that in mind. But the Kuchera seems to have a reasonable, I would expect to see 15 to 1 for most of this event, with brief periods getting closer to 20 to 1. And all right, I will wrap this up with just looking at the water vapor again here, as the system is already all self-contained within the United States. We can see all the pieces here, and it's just a matter of watching this shortwave dive down, interact, and bomb out over the next 24 hours. So I will say I have lived in the South for 10 years, and getting to forecast a significant winter event like this is a bit of a treat, professionally and personally. It feels like, that quarterback that goes and plays for a different team and then gets to go back and play for the home team. I originally grew up in Philly, and kind of the reason I got into meteorology is because of the blizzard of '96. So getting to forecast an event won't be of the magnitude of the blizzard of '96, but still very fun and interesting from a forecast standpoint. So stay safe out there. Obviously, the wind chills behind this are going to be significant, and I hope everyone can drip their pipes and things like that. So hopefully there's no major power outages that can cause a more impactful event. But thankfully, this type of snow event generally does not yield those power outages. But anyway, feel free to leave your thoughts and comments on this, and we'll watch this develop over the next 24 to 36 hours.